Hello viewers, I am Maithili. Today we are going to see 11 Cbse Maths complex numbers and quadratic equation miscellaneous exercise question number 12. Let's see the question. Let z1 equal to 2 minus I, z2 equal to minus 2 plus I. We need to find in the first subdivision it's given as real part z1 into z2 by z1 bar. This means conjugate of z1. Conjugate of z1 means changing the sign in between. It's the conjugate of z1, and in the second one it's given the imaginary part of 1 by z1 into conjugate of z1. So it is the bar means the conjugate of the given complex number. Now let me do the first one. The first one we need to find the bracket first, only then we can say the real part. So we need to find z1 into z2 by z1 conjugate of z1. So let me write the z1 value, which is 2 minus I into minus 2 plus I. So we need to do binomial multiply. Before that, conjugate of z1 is, here it is z1 is 2 minus I. So we need to write 2 plus I. Bar means, remember that it is the conjugate, not the inverse. It is the conjugate of the given complex value. Now we need to do binomial multiply in the numerator. So multiply both the 2 with both the numbers, similarly with I with both the numbers. If I multiply, it becomes minus 4 plus 2I here plus 2I here minus I square by 2 plus I. Now do the like terms, solve the like terms. So minus 4 plus, here it is plus 4I, here it is minus 1, I square is minus 1, minus into minus will become plus 1. By 2 plus I. Now solving this, we get minus 3 plus 4I by 2 plus I. Before finding the real part, there should not be any denominator part of a complex number. But here we have a complex number. To remove the complex number, we need to conjugate it. Conjugate is by multiplying both the numerator and denominator with conjugate of this denominator. So if I multiply the same way, we need to multiply it with the binomial multiply. So minus into minus plus will become minus, 3 2s are 6 here. Minus into minus will become plus, 3 into I will become 3I. Here plus 4 2s are 8I. Now again minus 4I square by, in the denominator it will be in the formula of a plus b into a minus b, which is nothing but a square minus b square. Now solve it. Here it becomes minus 1. So minus into minus will become plus 4. Here minus 6 plus 11I. Now here it becomes minus into minus will become plus 4 by 4. Here same way, here it becomes minus 1. So minus into minus will become plus 1. Now solve this. This becomes minus 2 plus 11I by 5. So we want only the real part. So real part of this answer is real part of z1 z2 by inverse of, with the conjugate of z1 is equal to, here take only the real part. While taking, we need to take with the denominator. Remember that we need to give the answer with your denominator. This is your final answer for this first subdivision. We'll move on to this. In the second one, it is given that imaginary part is 1 by z1 inverse. Okay, let's see here the inverse. It is a conjugate. So z1 conjugate is nothing but, we have a formula. I have given it in the introduction video. Those who have not seen this, please go through it. It is z, and z inverse is equal to modulus z square. So we have a formula of z into z conjugate is equal to modulus z square. So I am going to substitute the formula over here. 1 by z1 into z1 conjugate is equal to 1 by z1 modulus the whole square. Again we know a formula for modulus z, which is nothing but root of a square plus b square. A square is the real part and b square is the imaginary part. So 1 by, instead of z1 we have 2 minus I modulus square. Now substitute the formula, which is root of 2 square plus 1 square, the whole square, because we have a square over here. Square root get cancelled and it becomes 1 by 5, because here 2 2s are 4 plus 1, it becomes 5. And we don't have an imaginary, we have solved it, but they have asked for an imaginary part. We don't have an imaginary part, so we can take this to be 0I. They have asked for an imaginary part, so imaginary part of 1 by z1, z1 bar is equal to 0. This is not 0I, only we need to write the value, coefficient of I, which is 0 in the sum. That's all with the sum. Thank you.